This is part 5 of section 2.1. A manufacturer produces X items of a product at a total cost of 50 plus 2X dollars. The demand function for the product is P equal to 100 minus X. Find the value of X for which the profit is maximum. How much is the maximum profit? And then we're given some formulas here to recall. That the revenue function is X times P, where X is the number of items produced and P is this formula here. And then profit is revenue minus the cost, which is here. So the first thing we need to figure out is R of X. And it's X times P, and P is 100 minus X. So make that look a little bit better. We have 100x minus x squared. Okay. Now we're trying to maximize profit, so I need a profit function as well. Profit function is revenue minus cost, which is 50 plus 2x. So let's simplify, distribute and rearrange. The square term is what we want to have first, so I'll go ahead and do that. Minus 50 minus 2x. So I have negative x squared plus 98x minus 50. Okay. Notice that my a value is negative. That means that the parabola opens down, which does mean it has a maximum. That's something you may want to just keep in mind. Make sure you're not being asked to do the impossible before you go on. It just takes a second to think about that. Okay, so the maximum is going to be at the vertex of this. So I need to find negative b over 2a. So negative b would be negative 98 over 2 times negative 1. So this is 49. Okay, so what we have found is the value of x for which the profit is maximum is 49. Okay, so if this manufacturer makes 49 items, then they have maximized their profit. Now, what is that profit? So we need to find P of 49. Okay. So we need to take this value and plug it in here. This is negative times 49 squared. I see this mistake all the time. People do this. Okay. This negative does not belong inside the square. That's negative 1 times x squared. So this is negative 1 times that. You're not squaring the negative. It's one of those things that you know, I know you know, but it's very, very easy to mess up. So be careful with that. We don't have a problem with it if it's a number other than a 1 in there. If it had been negative 2, nobody makes that mistake. Okay, so negative 49 squared plus 98 times 49 minus 50. Okay, this is negative 2401 plus 4802 minus 50, which gives us $2,351. So if this manufacturer produces 49 items, they've maximized their profit, and that profit is $2,351. Okay. A rancher with 120 meters of fence intends to enclose a rectangular region along a river which serves as a natural boundary requiring no fence. Find the maximum area that can be enclosed. So as soon as I start hearing geometry words, I know that drawing a picture is likely to help me. So I have this river, which is a natural boundary. we're going to put in a rectangular enclosure like that. And I know that these three sides need to add to 120. So let's say that this is X meters. What I know about rectangles is that if this is X, this is also X. So how far is this? Well, I had 120 meters to start with. I've used X, and then I've used another X. So this side length is 120 minus 2X. We want to maximize the area of this rectangle. Well, area is length times width, so the area would be X times 120 minus 2X. Distribute. And then rearrange with our square term first. Okay. This is a parabola that opens downward, so it does have a maximum. We're not being asked to do the impossible. Let's find the vertex. Remember, this is essentially a plus 0 here, so if you need that C value, it's there for anything. Our vertex is, I need to find negative b over 2a. Negative b will be negative 120 over 2 times negative 2. So negative 120 over negative 4, which will be 30. So that means that if this side is 30, which means this side is also 30, then we have maximized our area. So this would be 120 minus 60. So that would be 60. So our maximum size, the dimensions of our enclosure will be 30 by 60. We're asked to find the maximum area. So this area would be 30 times 60, which is 1,800. Our units are meters squared.